Hello, this is Michael Delvaux for yet another geology hike around Denver area. But before we begin, I'm on Lookout Mountain taking a look down upon the area. So Denver is off in the haze over in that direction. And before us we see South Table Mountain, this mesa right here, and Coors Brewery down there. Again, this is Golden down below us here. And North Table Mountain, that mesa right there. And as far off as you can see over in that direction is Ralston Buttes. And Ralston Buttes back in the Paleocene was a volcano, the neck of a volcano being mined right now. So that volcano erupted 4 times in the Paleocene between 64 million years ago and 63 million years ago. So it was active for 1 million years. And that lava flowed from that volcano over to what is currently North Table Mountain, but that was all the base of the valley at the time. And what we see at the top of North Table Mountain are the last 2 flows. And down at the north end, you might be able to pick out one of the earlier flows. So those flows continued across what has later been cut out by Clear Creek, across to what is now South Table Mountain, and all in that area, and flowed way out as far as you can see there. For our hike today, let's go to North Table Mountain off of Highway 93, and let's check out those lava flows. Okay, I'm at the North Table Mountain parking lot for the North Table Mountain West Trail, and that trail is right there, and there's an old quarry up there, and it's the old road to the quarry. Let's talk about igneous rocks. Igneous rocks start out as a molten magma. If that magma cools slowly underground, it is plutonic. If it cools fast above ground, it is volcanic. If it is high in silica content or quartz and potassium feldspar, it is a granite or a rhyolite. If it is low in those and high in plagioclase feldspar, it is a gabbro or a basalt. There are many intermediate classifications, of which the middle is diorite or andesite. The Table Mountain lava flows are closer to an andesite classification. The magma was derived from a deep basalt source that intermixed with granite above and followed the steep golden fault on the way up. This intermixing resulted in a potassium-rich basalt. So the technical classification of this lava by the USGS then is called a shoshonite. Okay, so we've walked up the trail a ways, and here is the first lava flow outcrop right by these trees right here. And 3 and 4 are up there. So if I look at the base of that lava flow, there appears to be a channel right up here. So let's go up and take a look. Okay, I'm at the base of this lava flow, and here is that channel, and it looks like it's debris. The debris itself looks like scoria. I can see gas vesicles, gas bubble areas throughout these chunks of debris in here. This was a volcanic debris flow following a stream channel prior to the lava flow. So what I think happened is that there was an explosive event at the volcano which ejected a lot of scoria. Then at a later time, some kind of water event gathered all these scoria blocks in this stream and down this stream channel. Now I'm here at the lava flow itself, and look, there's all these crystals, these black, very small crystals. They are pyroxene. On these good crystals, you can see 90-degree cleavage angles. That is a good indication that these are pyroxene and not amphibole. In a rough sense, these crystals align in the direction of flow. And here's another nice one. Okay, so let's go on up and see what else we can see. While we walk up the trail, let's talk about Bowen's reaction series. As magma or lava cool, the minerals precipitate out at different temperatures. Calcium plagioclase and olivine are the first to precipitate. As more and more calcium plagioclase precipitates out, the actual magma chemical makeup is different, which ends up causing olivine to chemically react with that magma and change into pyroxene. And likewise, as more sodium and calcium plagioclase precipitate out, the pyroxene then reacts with the magma and changes into amphibole, and on down the chart. Now in a lava, the temperature tends to drop relatively fast, and all of these minerals precipitate out really fast and don't have time to form macroscopic crystals. They're rather microscopic crystals. So the question is, why did the pyroxene form macroscopic crystals? The USGS report does not address this question. The report does address the minerals that were found at various locations. Except for the pyroxene, these minerals are mostly microscopic. It shows that biotite is observed. Biotite is lower on the Bowen's reaction chart. So the crystallization process did go according to theory. Therefore, we will leave as an unanswered question as to why the pyroxene formed larger crystals. Okay, we were down at that outcrop right out there, and a lot of the sites here are recent erosion and landslide deposits. Up until you get to that one right there. So that is Denver Formation, the actual formation that these lava flows belong to. And that's lava flow number 3 right up above there. So let's go take a look at this outcrop here. Yeah, so this is a sandstone and pebble conglomerate. Current markings pretty much showing, especially right there, that it's south flowing. Okay, and I'm looking at the pebbles within this conglomerate. Most of them look like pieces of scoria having little gas bubble indentations.
This and the sandstone look like they are derived from the volcanic debris of some sort, so I'll call it a volcaniclastic sediment.
So I'm at flow 3 now. It's rather thick. Let's go up there and take a look. So in here I can see both pyroxene and some feldspar crystal, as well as some scoria that's gotten in here. Okay, I'm now above flow 3. This is flow 3 here. This is flow 4 there. And here is a conglomerate that lies between the two. The base of the conglomerate looks to be lower than the top of the lava flow. That's because there's a normal fault running right here, which dropped the right-hand side. So let's go take a look at this conglomerate. So it does look like this conglomerate picked up pieces of scoria. This is a fairly large piece. It's not rounded. And then the rest look pretty andesitic. This one here looks like it has pyroxene crystals in it, so it's probably derived from the earlier flow. Here's a better view of that large piece of scoria. So let's go look at flow 4. Okay, I'm at flow number 4. Let's see, right over there is another bed of scoria. Flow number 4 is not as thick as flow number 3. So let's go take a look. And in here, again, I see pyroxene and I see some crystals of plagioclase. Also in here, I see gas bubbles, elongated gas bubbles, indicating a direction of flow, which would make sense because this is flowing roughly south. Okay, I've reached the top, and this is looking towards the northwest. Also, there's this very large quarry. So at the top here, we'll go around this quarry and follow the North Table Mountain Loop Trail, which will go on the east side of this quarry. At the trail junction, you can see Lichen Peak, the tallest point on North Table Mountain. We will not go that direction. And we're walking along the top of Lava Flow 4. There's the highest point right there. This trail will eventually go down over there, that gully there below the 4th flow. Now I'm located where the North Table Mountain Loop Trail descends below Lava Flow 4. And one thing I do notice over here is largely the same makeup, but there are some larger feldspar crystals that have crystallized out through this area. Okay, let's continue on down the trail. Same outcrop, but notice here that there's some zeolite crystals. Zeolites are a group of minerals whose chemical structure incorporates a molecule of water.
In this case, the water was probably absorbed by the lava as it was going through the water table, or as it was passing over a stream or something. Zeolites have many industrial uses, such as absorbents and catalysts. Eventually, you come to this large tailings area. So let's go up that little trail right there that goes up to the top of those tailings. So you can see there's been a lot that has been quarried away here. And you eventually reach the top here. And this is where the quarry was. This quarry was first opened in the 1870s by Arthur Lakes, who was looking for zeolite crystals. Okay, so here's flow 3, and all of this quarrying debris has zeolites in it. And if I look right here, you can see a really nice set of crystals right there. They're just all over the place. Another thing to notice in this quarry are these cubical blocks. In the early 1900s, they quarried this rock into blocks as paving stones for Denver's streetcar system. This stone was also used for monuments and tombstones. So let's take a closer look at some of these zeolite crystals. This one is anacline. This one is acrophyllite and scolecite, I believe. The School of Mines Geology Museum does have a display of all of these North Table Mountain zeolite minerals. Okay, to summarize, the Denver Formation, here listed as TKD, had 4 lava flows over the course of 1 million years. Our trail did not go over flow 2. These flows have a unique mineralization of pyroxene, plagioclase feldspar, and zeolites that all form macroscopic crystals. These flows were once on the valley bottom, but after erosion, they become the top of the mountain. Now I'm back down into the town of Golden, where people are enjoying their day under this very beautiful backdrop of North Table Mountain. This is Michael Delvaux. Thanks for hiking with me.